How's it going, guys? We're going to go over some problems that involve finding atoms from grams and grams from atoms. For example, like how many blank atoms are there in a blank gram sample of blank. So first one we're going to start off with is, let's see, we're going to have how many Ca atoms. We're looking for Ca atoms in a 25.5 gram sample. Okay, so first of all, what do we have? We start with what we have, 25.5 grams of calcium. So now, basically what we're going to try to do is we have to multiply it by something that can get rid of this, because eventually we need to work our way all the way over to atoms. So first off, how many grams are there per mole? Check out the periodic table. We find that calcium has 40.08, so we can round that up to 40.1 grams per 1 mole. So now we've gotten rid of our grams. Now we got to take our mole and run with it. So how many moles are there in one mole? 1 mole of Ca, or 1 mole of any atom or any element, is 6.022 times 10 to the 23rd atoms. That's Avogadro's number, and that's one you kind of just have to commit to memory at some point, unless it's provided for you, but it's easy enough to remember, I think. Now we just multiply it out. So we have 25.5 times 6.022, let's see, times 10 to the 23rd equals, I just multiply everything on the top and then divide by everything on the bottom. Divided by 40.1 equals, we get 3.829, we'll round that up to 3.83. Times 10 to the 23rd atoms of calcium. So that's not too bad. Okay, next one we have, we're going to do how many, let's see here, how many NaCl atoms in a 112 gram sample. First off, whenever you have something that is you can't just find from looking at the periodic table, just do a quick calculation. So for Na, we have 22.98, we'll round that up to 23. And then for chlorine, we have 35.45. $58.45 grams, and that's going to be our molar mass for NaCl table salt. So now we're going to start off with that, because, well, actually we have the 112 gram sample here. So we have 112 grams of NaCl. We can multiply that out. In order to get rid of the grams of NaCl, or just get rid of grams, we're going to put 58.45 grams NaCl on the bottom, which we know is equal to 1 mole of NaCl. Now we can keep going across. We've canceled out the grams of NaCl, now we want to cancel out the moles of NaCl. So we can put 1 mole NaCl, and like I said above, we know that any atom or any molecule has 6.022 times 10 to the 23rd atoms per mole in chemistry. And we just multiply that across. We have 112 times 6.022 times 10 to the 23rd equals, divided by 58.45 equals 1.15 times 10 to the 24th. Atoms of NaCl. Cool. All right, so one more. Now we're going to try one that is the reverse. We're going to try to find grams of, let's see, grams of calcium in a 6.45 times 10 to the 23rd atom sample. Of calcium. So this might work out to be kind of a weird problem based on the numbers, but let's give it a shot. Let's see how it goes. So we're going to start with 6.45 times 10 to the 23rd atoms, Ca. That's what we know we have. And we're going to try to get rid of atoms of Ca. So we know that there is going to be 6.022 times 10 to the 23rd atoms of Ca per 1 mole of Ca, calcium. Now we have moles on the top. Now we'll get rid of moles on the bottom. 1 mole of calcium is going to equal, let's check the periodic table. Calcium has 40.08. We said that's going to be, we're going to round up to 40.1. Now we've gotten rid of atoms. We got rid of moles, and we're going to end up with grams. So we basically just did the exact opposite of what we did in these previous problems in terms of the the order of the conversions. So now we're going to calculate this 6.45 times 10 to the 23rd times 40.1 equals, and then we're going to divide that by Avogadro's number, 6.022 times 10 to the 23rd. And we're going to get 42.95. 42.95, and we're going to end up with grams of calcium. So yeah, hopefully this helps someone. I think these problems, it shows both ways, and regardless of the element, just make sure that if there's multiple elements or if it's diatomic, if it's a compound, just calculate the molar mass by adding up each one individual. Okay, I hope this helps someone.